Hi everybody, welcome to the stream. So, I know it's been a while. It's been really busy last week. I had to help a friend who's working on a college project do a convex hull algorithm, which is super fun. It had to be done like super quickly, but it was fun to like learn and work on a convex hull algorithm. I think for like recreational programming, convex hull is a very fun algorithm. And on top of that, I'm currently working on a web development project for a local Dance Dance Revolution tournament our community is going to be hosting. I am the like tech person behind all of that, so that'll be fun. So yeah, quite a bit has happened over the last like 1 to 2 weeks, so it's been a little busy, but we finally have made some time to do some streaming today. So hello everybody, and welcome to the stream. So today, I wanted to take the sprites that my sprite artist has developed for the Chapter 4 monsters, and I really wanted to start implementing them into the game. So the way this normally works is that I have to take the sprite sheets and I have to first verify like they're ready to be used in the game. One thing I already did was I made sure the sprites were like sized accordingly. They were put onto a grid and they're not like spaced weirdly or anything. So that's one thing we have to do. We also have to work on the snake monster because the snake monster actually doesn't have a strategy for whatever reason. Forgot to do it. Oops. So we have to do that as well. But here's where we're gonna start. We're just gonna go down the list of Chapter 4 monsters and start implementing their animations. And the way that's gonna work is first I'm going to verify the sheet themselves. Now I have a suspicion they're actually not in the right order in terms of facing directions. So 4-way monster sprites have facing directions, north, east, south, west. That is actually the order the game engine expects them to be in. So if they are not in that order, we have to actually fix them. So just looking at the sprite sheet here, we can see that this skeleton is actually south, north, east, west, which is not quite what we want. And I believe the whole sprite sheet follows this. So this is going to be the first thing we have to fix. And this has actually been a problem with working with, just artists in general, is they don't necessarily follow the guidelines you need them to follow in order to have game ready graphics, right? Like some of these sprites weren't even aligned to the grid, or they were like off-centered, right? It's like when implemented into the game, they won't quite look right. So that's what we have to do in order to make it like game ready, I guess, is once the art is received, then the art has to be made into game ready assets. One thing I would like to do is not have to do all this manually because it's very like time consuming. I think it's finally time we developed a little tool that lets us specify like, okay, what size is each sprite? And then it will adjust or shuffle all the rows to be in the correct order. Because basically every 4 rows should be one particular sprite animation. So if we look here, there are 16 rows to this monster's sprite sheet. And so we needed to go through all these and every 4 rows, shuffle them to be in north, east, southwest order. So I think we're going to develop a little program that will do that for us today. And then we'll be able to use it when we get to Chapter 5 as well. Because this problem has cropped up every time and we could spend the next like hour or today's stream working... Oops. I just opened the project solution twice. We could spend a whole day working on this, but I think it'd be best to design a little tool for it real quick, since we can. So I'm just gonna make a new C++ project here, and we're going to call it the, let's call it the sprite sheet, organizer? I think that's a good way to put it, right? Okay, so we'll call it the sprite sheet organizer. So this thing is going to use the Pixel game engine as well And the way we're going to go about this is the Pixel Game Engine can load PNGs via, I believe it's libpng. Something like that. And because it uses libpng, what we can then do is also use another function of libpng called like save to PNG. So we can rearrange or manipulate the pixels in the files, the images, and then we can resave them to another PNG image. And that's how we're going to accomplish this today. So I need the OLC Pixel Game Engine real quick. So let me grab that. The OLC Pixel Game Engine is a single header file, so it's very easy to just go into the repo and grab it whenever you need it, and then paste it. OLC Pixel Game Engine. Also, happy Monday to everyone. Hope everybody's doing well. Okay, the OLC Pixel Game Engine also needs to be running on C++ 17. It looks like 20 is my default for Visual Studio Insider, so that's nice. And we're just going to copy the example at the top and make sure that runs. And then we'll have a ready-made application to start building our project on. So just make sure this compiles. It will also blur my screen. Because of... yes. Compression! Alright. Someone special 10, please. Hi, Plasticky. Good to see you. Welcome. Alright. So I don't need any of this. We're not going to utilize this. In fact, we're probably not going to use the update function at all. What we need to do is we need to accept some kind of like input file name. So I think what we'll do in main is we'll accept, I think it's like char star args and char, or is it like int number of args, right? Something like that. I think that's how this works. So then we'll do, let me just output it and see what happens. So arg n. And if I'm not mistaken, this should produce like a number, probably 1 or something, either 1 or 0. Or it produces a big number. So this might actually be the char star pointer. In which case I think I have this backwards. I don't know. I don't usually utilize this, so this is kind of interesting. Okay, so now we have the number 1. So presumably there's one argument. So then the other one is the pointer to the args. So we can say for int I in standard ranges iota view, which I need to include. Also range, I think this one's in C++ 20, but I could be wrong. It looks like it recognizes it, so we'll do 0 to argn. And then we'll say, for each argument, go ahead and output. It's going to be char star, so it should automatically print as the, as a string. And we'll just take a look and see if that works. That's an @ symbol. What does that mean? Alright, maybe I need to look up this, because that's definitely not right. Main, CPP. The main function wants to be int argc char star argv array. Oh, it's a char star. Well, char star should work then, shouldn't it? If I just do args I. Pointer to the first element on an array of argc+1 pointers. The last one is null, and the previous ones, if any, point to null terminated multi-byte strings. Do I have to write this in here? I feel like... oh, because it's like a pointer to a string, to a list of strings, and strings are element arrays too. There we go. I forget about that little detail. It's actually... if I really wanted to, I could just write char star star here. That makes more sense to me, and it's the same thing. So I like that syntax better. Anyway, yeah. Hi there, Hui. Good to see you too. Yes. It is afternoon for me, so you guessed correctly. Nice to see you again. I know it's been a minute. Okay, so with this, we can accept either one or more arguments of file names to change. I think another argument we would like to put is the order of the sprites, like the intended order. So I think what we will do, it's let's force argument 1 to be the conversion. So for example, let's say we wanted the order, like right now, it's south, north, east, west, right? So if we write in our program that there's south, north, east, west, what the program should do is rearrange it so it's north, east, southwest. If it knows that's the current order of the sprite sheet, then it can calculate which rows are which and flip them all for us. So I think that's going to be the goal. So the first argument is definitely going to be that. So let's say we need at least 3 arguments. So if argn is less than 3, then we're actually not going to run the program. And we'll just return like a -1 or something. Negative numbers are typically error codes, so that just lets the OS know, hey, this failed, right? And then in here, we'll just output, hey, not enough arguments. And we'll just give an example, I guess, to be nice. We'll say like, what? This is called Sprite Sheet Organizer. Sprite Sheet Organizer. And we'll put here, it's going to be like northeast, southwest. Followed by, what? File names? File names. Something like that, just so we know. And then we should be okay. Hello, you're back. Last time you were streaming. Oh, I'm much better. Yeah. We're done with sickness. It's been a couple weeks now since we've dealt with that, so yeah. I'm feeling amazing today. I hope you're doing well. So yeah, today we're making a little tool to help us organize or rearrange animation sprite sheets that are not correct. So with that, let's first read in, I guess, the directions. So how do we want to store the directions? I want it to be kind of like, we have an enum for directions. I don't know, I could just specify like the orders, but I think like what we really want to do is have either an enum or like a map of directions. I think a map would make more sense. That way we can immediately map like the characters straight to some useful like thing, but they also need to be like in a way in a certain order. So like I think we actually want, because I want them in a specific order, to be like vectors, but it's more like the argument specifies the order, and then we just iterate through into, I guess the directions don't really matter. We just have to say, okay, which position is the N in? It needs to be input slot 0. And so on and so forth. So I guess what we're doing is we're storing like four offsets, right? It's gonna be like, also, hi there, Creton, welcome. So we're gonna say these are four offsets. I'm just gonna call it that for now. The number of row offsets that each element is adjusted by. So for example, in here, the sprite sheet is south, north, east, west. So that would make the offsets be 2 for this one, because this needs to be 2 down from where it currently is. This one wants to be -1, because it's one row below where it should be. This one is -1 because it's one row where it should be. And this one's 0 because it's actually in the correct spot. If we're aiming for northeast southwest, we'll have the program store what each offset is relative to its current position, so that it can rearrange them correctly. We're also making the assumption that every row, or every 4 rows, is in the same direction, which is a pretty safe assumption because the sprite artist usually does it just in that order. Hi there, Kyle. Welcome. I think you're right. Usually Kyle is here first and is very early. But yes, welcome, welcome. So with these row offsets, let's start by parsing the direction, which is going to be the second argument. So we're going to say 4 and I is 0. This is like our index. I'm actually going to use size T here. Index into our string of args1, which is the second argument. That's going to be the length we actually don't know the length of this unless we do like string strlen, which I guess I could do. Iota view from 0 to strlen. I wonder if we have to include a header for this. Oh, it looks standard. Okay. But yes, technically, for each one of those, we're going to parse them into row offsets. But we're interested in the first 4, so we're not even interested in all indices. But we assume there's 4. If there's more than 4, I guess or if there's less than 4, I guess it's going to break. Which I guess is fine. Should we throw if that happens? If strlen of args1 is less than 4, or let's just say not equal to 4. Let's throw. Because I don't think we care if it's not 4. Right? I think that makes the most sense. So then in here, we're going to parse each one. So we'll do a switch statement where we take args1 index and we're looking for the characters N, E, S, and W. And if we get a character we don't recognize, we can also throw because we don't recognize it. So for N, we're going to say that's the first row offset. So row offsets 0 will now be equal to whatever position the index is. So for example, it's supposed to be, N is normally supposed to be 0. So if it's in, let's say, position 2, then this should return -2. So we're going to do 0 minus index for this one. And then I think we just go down by 1 for each one. So for E, it should be like 1 minus index. So for example, if the east was on the 3rd row, then it would be 1 minus 3 needs to go 2 up. So I think this is the correct math for this. So we just keep going. And then we just have to adjust the row offsets number. So I guess at the end of the day, the row offsets number and the index number and the amount to subtract is the same. So it should look something like this. So for example, if the west row was in the first slot, in slot 0, then we have to move it 3 down. That's what these represent. So once we have that parsed, the next thing we can do is go ahead and load our image. So the next argument, or arguments, should be our images. So we'll go ahead and load all those into a vector. It should be a vector of renderables. Images. I'll go ahead and say we're using namespace OLC. I like to use the namespace OLC. It's not super polluted, and since I use the OLC Pixel game engine a lot, I like to use that as a shortcut. So that makes renderable unknown type. And then we can start storing our images in there. So basically, we'll say for char star string or file name inside of args. We have to iterate through all of them though, don't we? So it'll be like, let's change that. It'll be like size t index inside of standard ranges from 2 to whatever argn is. We will look for what the file name is by saying this is args index, and then from there we can read it. So we're gonna need OF stream. It might actually be already included in the OLC Pixel Game Engine header. So standard IF stream, input file stream using file name, and then we're gonna need standard get line. We're gonna say while file good, we need to name this with the local variable file. So while file good. Well, actually, there's already a reading function in the OLC Pixel Game Engine, so we should just load that. So what we should do is start up a new renderable here. So images, and place back a brand new renderable. And then inside of, you might need to be explicit. Just copy a new blank renderable. And then, actually, I don't know if that works. That might not work. Maybe I should just do blank, no arguments. I think that will work. We're just inserting a new element, and then we can do whatever the element is. I think you'll return it. Yes, so it returns a reference to it. And then from there, we can go ahead and load in our image via file name. And realistically, we only have to load in the sprite. We don't actually need the GPU side of it. So maybe I should change this to sprite. Because what a renderable does is it links both a sprite and a decal. And a decal in OLC Pixel Game Engine terms is just the GPU side, the GPU texture, while the sprite is the actual pixel data. So then I think the sprite constructor just becomes the file name itself. So we can just do this now. And that should be all we have to do to load the images. So if I were to breakpoint here and go ahead and run this application, well, for now it should fail or complain to us. If there's no syntax error, can it not initialize this? Oh, I think the array needs to be default no matching token. Sounds like a syntax error. Did I miss one? If I did, I'm not seeing it. There, one there. What are the benefits of using IOTA view instead of a for auto IT args plus 2? IT is not equal to args plus argn increment IT. I think I'm just not used to seeing it that way. Like, I don't think of this as like... I don't think of it as like the start of the array where I can just like look up by moving through it. The benefit is I can read it better. That's the benefit. This is weird. It's saying it's on this line. How is this not matching? What is this matching to? I don't understand. Oh, this one went red, so there was something. This ends the switch. Okay. So my indentation was off. Cool. Better. Okay, so that crashed. That should have crashed. Yeah, it exited with code -1 because there's not enough arguments. So now we can throw in some arguments when we start it. I think you can do it through here. At least I would like to. Command line. Specifies... No, that's for pre-build. How do I run it? Debugging. Command arguments. So we're gonna do... Just as a test, we're gonna say this is south, north, east, west. And then the second argument is the actual image. So we're just gonna give it an image path. Like so. And it's going to be skeleton space warrior.png. Skeleton warrior.png. And then we should be good to try it. Exception thrown on load image resource. My val2 is null pointer. Okay. Can find the image? Is that what we're saying? Loader's empty. Oh, we have to initialize the engine first before we can do this. So engine needs to be initialized, then we can do engine stuff. So let's go in here, actually, to the onUserCrate function after the engine has been initialized. I need to move these two up here. Y'all need to... Oh. Hidden window. Okay. This goes up here. Should be okay. Oh, we don't have args anymore. I mean, I guess I could store them. Images to load or something. Standard string. Images to load. And then down here, we'll just iterate through them and insert them into there. So this becomes images to load down, place back. Oh. And I think if you provided a char star pointer, it'll convert it to a string. More than likely, right? And then we just iterate through those up here. For standard string file name inside of images to load. Let's try that. It's just in the ranges library, so the program has loaded. I didn't put... my breakpoint died, but... let me do that again. I just want to inspect the variables. So images to load, size of 1. We see the path is correct. We have one sprite. It does successfully load all the pixel data for it. And then finally, the row offsets. So it's going to move the first row up by 1. Is that right? Wait, that doesn't sound right, because south is first, right? This is south. So south wants to move 2, but I think the way we have to specify it is first element moves down 2, so on and so forth based on that. So instead, what we're trying to accomplish is we start at index 0 and we increment it to specify how the row offset works based on the character. So it has to look like this instead. So let me try that one more time. Because we specified as in south, north, east, west. And the target goal is to get them to be north, south, northeast, southwest. So north, or now row 0 needs to go 2 down, row 1 needs to go 1 up, row 2 needs to go 1 up, and row 3 is correct. So this now produces the correct numbers we need in order to manipulate the sprite data. I disagree, but I actually don't know if it's more modern and efficient. Because I would argue the added complexity, and you should see some of it. Trying to do some of the range syntax is ridiculous. So I actually disagree there. I don't think it's any more useful, and it might not even be more efficient. I've never I've never done a... What do you call it? I've never profiled it. So I actually don't know that. What I need right now is... So I have an old project called... Trying to think real quick what it's called. But basically it was when I was doing Advent of Code. I think in 2020... Is it 2022? But basically, I had a visualizer using the OLC Pixel game engine. And one of the features I did was I made it so you can visualize at any point in time if... I don't think it was 2022. I think it was the following year, 2023. I think that was... Oh, I think I started putting everything in one place because this made more sense. But basically, I would make like a visualizer project, which I can then use the Pixel game engine to output stuff on the fly and also output images if I needed to. So I'm trying to see if I can take that and use it somewhere. I know I had to do it for a particular day of Advent of Code, and now I regret not documenting that. Because it's like... Is it this one? But basically, we can implement a function inside of libpng to give us access to save to PNG. I might have to just re-implement this. It looks like I can't find it. But anyways, there is a function, actually I have to pull it up here, libpng save to PNG, that we can utilize because it uses libpng to read PNG data. So what we're going to do is look at the documentation, or maybe the source code. I think it's the source code. But basically what we want to do is write to the PNG file, because let me first confirm libpng is correct here. So here's image loader PNG. Default on Linux. Oh, maybe not. Oh, we use GDI. Load image resource. So can I confirm this is what happens if I just breakpoint here? Do we go in here? Okay, so we use GDI. So there must be a way to call GDIs like save to PNG. There's probably a way to do it, right? I'm just gonna explore real quick. Save? Save. File name, encoder. That kind of looks like what we want, so maybe we can utilize this. So let's see here. Let's look up GDI plus, I guess, save to PNG. Maybe that will help us. Looks like there's a snippet here. Jesus. Okay. Let me just see if I can save. So get CLSID for extension. I am save after getting some kind of encoder. I mean, it looks easy enough. They say it removes verbosity. It can, but it can also make your code look uglier, right? Like, for example, I think it was in inventory. If we just take a quick peek here. So it can, right? Where is a good example? Let me find like... Oh, you know what? It's probably used in order to do the range functions, like... Here we go. So this is one way you can use like views and ranges, right? It can condense things so it's less verbose, because if you were to try to do this before, like prior to C++20, it would be like standard transform. You would need, well, this is a lambda, but you would have like the list here, whatever your target list. So like full list.begin, comma full list.end, your two iterators, followed by this lambda. And then you would of course have to return, because this is like a different vector. Then you would have to write something to iterate through all those items and then turn them into a new vector. So like, it does remove a lot of verbosity, but you have to be able to like dissect this entire line, which is pretty dense, right? I don't know anything about C++ 26, no. It's too new to really look at yet. Dave, this is Visual Studio. It's just highly customized. It has an extension called Claudia IDE, which lets us do like timed wallpapers in the background. And it also has the transparency. And on top of that, I usually hide my stuff. So like I have all these auto hidden tabs. That way I just have all my code on screen instead of a bunch of like windows always popped out everywhere. So yeah, that's why it might look a little bit not Visual Studio-y. So it looks like writing or saving to a file in GDI is not terrible. I don't see anything here that's really complicated other than making sure the file name works, because it's like, apparently this wants to find the dot and that determines the CLS ID for the extension, which I guess I could hardcode to be PNG because it only accepts PNG. Like, can I just hardcode this? So what does this even do? A CLS ID is a globally unique identifier to identify a COM class object. If your server or container allows linking, you need to register a CLS ID for each supported class of objects. Get CLS ID for extension. So specifically, what does the extension one do? I guess this is the wrong place to look for this. Image encoders. Alright, hold on. Let me go to Google. Sometimes DuckDuckGo doesn't quite get us there. Literally, there's like nothing about this. Like, what? I would expect there's like documentation, not necessarily just a bunch of code out in the wild, you know? But maybe we have to read about encoders, and maybe that will tell us more. Like, image encoders in GDI+. Something like that? Okay, here we go. Provides the image class in the bitmap class. Listing installed encoders. Retrieving the class identifier for an encoder. The MIME types of the encoders are as follows. Get image encoders to get an array of image codec info objects. So I guess it's not something we can really hardcode. We just kind of provide .png and it's supposed to tell us? Okay. I was just hoping I could like plop it in and not have to worry about this. It just looks kind of funny, right? But I think we can just take this. This is pretty much one for one what we need. Oh, what's this? Hold on. Save image resource. Is this like unimplemented? There's like a stub for it. Okay, well, if that's the case, I'll just use that. Let's see here. I don't think... I mean... The messages are nice. I guess I'm not doing this. Image is supposed to be the... Are we supposed to have the, like... Do we have to, like, read in the image again? Because, like, we can read it, but then, like... Do I have to actually... It's like it assumes we stored the bitmap or we reread the bitmap. It'd be like... Oh. This is actually a function in here that we need to, like, include, I think? Or is this, like, the GDI plus source code? No, this looks like an implementation of GDI plus. This is interesting. But like, okay, so... An image... I also want to see if somebody's already done this in the OLC Pixel Game Engine community. I'm pretty sure somebody has. I'm just gonna take a quick peek. Because I've done this in libpng, but like... saving sprites to PNG? Let me see. How to add functionality to write OC sprite to PNG file. Initially add to 215, point to 217 using STB image. The excellent STB image can be used instead. Oh, that's what they do. For including the OC Pixel Game Engine header, stbimage.h works on many systems. Okay, I do like STB image. I guess this is the route we're taking if it's already documented and easy enough to do. I guess that would be significantly easier then. Good thing I checked before I dove into this rabbit hole. So, stb underscore image .h. And then I think there's just like a macro you set to say to make Pixel Game Engine use this instead. Hi there, Saduchi. Welcome. Yeah, so we're just gonna... wait, where'd the file go? Oh, here it is. Okay. So... there's 4 changes need to be made in the OC Pixel Game Engine header file. Add an ifdef with save to file in here. Okay. Under the sprite class. Sprite. I want the declaration of it, please. And then we'll just add it right here where load from file is. So... yeah, if we have this defined, then I guess it's going to use it. So I think in main, we'll just go ahead and declare that now, because I'm pretty sure that is going to be required. Okay. And then save to file now has to be implemented. In the implementation, add the implementation of this additional method. Okay. So there's a load from file, and I guess save from file goes here. And then in order to write PNG files, you must define an additional flag and include an additional header file. Am I supposed to have this header file? This is in stbimage.h. If defined, OC... oh wait. This isn't here. Pragma region, image stb. It goes right here, apparently. Oh, is this the stb image, right? Is that what we downloaded? I think we need stb image, right? There's a stub implementation for save image resource in the class image loader stb. Make an addition there to actually write the sprite to the file. stbi write png. Save image resource in stb. And then apparently this comes from that header, so I think we need that header now. We added this. Here's our example of use. You just call save to file. So now I think I need stb image write. stb image right? That's not what I was going for. stb image right.h. Here we go. So I think with these 2 headers we should be okay. Perfect. So now I guess what we can do is, let's just try saving the images to like the local folder and see what happens. So we'll do, we'll do it this way. For sprite S, I did not mean to type that. Images S dot save to file. I'll just name them like numbers, so I'll do like size t int trying at 0, and we'll just increment it for each save. Convert that to a string. Standard to string. .png. I'll just see what happens. sprintf. Concern. Oh my god. Okay. We need to add underscore CRT secure no warnings to disable our deprecation of sprintf, or use sprintfs instead from stb image, right? I'm not concerned with the security of this pet tool that only I'm going to use, so I'm just going to go into, I want to say it's here. Just go to command line and do, I think it's, is it here? Yeah, it's like slash, I want to say it's slash D. I don't see an example here. Oh, here we go. Yeah, so I'm gonna do slash D. It's in the compiler. And I want to just add underscore CRT no secure warnings. I think that's what we have to write. Underscore CRT secure no warnings. I flipped these two. Okay, let's try again. Okay, so it ran. So we expect if we loaded that file, there should now be a file inside of here. Under... This is called Sprite Sheet Organizer. Where'd it go? Is it my sources folder? Let's see. Repos. Oh, it did end up in here. Cool. So there's a 0.png. And the 0.png is an exact copy of that image. So it has successfully saved the image to another file. So now we get to manipulate it. So the way we're going to do that is iterate through our 4 offsets. Well, first we have to figure out the size of the image. So I think the width is easy. We just divide by 4, but the height, we might have to specify that as a parameter. So like this one is, I believe, 48 by 48, because I think the grid's 12 by 12. So yeah, this is 48 by 48 for each individual image. So I think we specify that inside. Or do we assume... I guess we assume sprites are square. They're always square. So if we know the width is 48, the height has to be 48. So we could deduce it that way. So let's retrieve the height, or yeah, retrieve the width. So we're gonna say image width, which is going to be sprite s dot width, and then we're going to say the height. Oh wait, it's width divided by, well, it's not always 4 either. That's the other problem. Yeah, we have to specify. Okay, so let's add an argument to our program. I just realized, how does it know that it's 4 frames? Some images have 5, some have 3. We don't know. So in here, let's say argin has to be greater than or equal to 4. First argument will still be the names. Now the second argument will be the sizing. I guess I could like comma separate or x separate them. So the expectation is to put like x by y to specify the dimensions. I guess I'll put here width x height. That makes more sense. And then in here we'll parse that. So we're looking at the second argument. So this is the dimensions. And then we're gonna store that in here as a vi2d image dimensions. So dimensions is args2 converted to integer and save it to image dimensions. I think I'm just gonna compact this. So image dimensions becomes equal to s2i. No. we need to first split it. That's why I did that. Okay. So yeah, we have to parse it. So we'll do X marker is determined by finding where in dimensions there's an X. And if for some reason it's not found, then we throw, because that should not happen. Otherwise, we proceed and we parse by that. So then we say image dimensions X becomes S2I of dimensions substring from 0 to the marker. And then Y becomes the substring from X marker plus 1 to the end of the string. Now that we know the width and height of the image, we can then adjust the rows accordingly. So for every row in the image, so let's say 4, I think it would also be a good idea to now save by images to load, like the actual file name. So I'll go ahead and put that there instead. Images to load index, which then needs to be incremented at the end of each loop. So now we have to iterate through every row of the image. So we're going to say int row in standard ranges, starting from 0, going all the way to whatever the height of the image is. So s dot height, divided it by the image dimensions dot y. That tells us how many rows there should be. And then from there, the actual x position, or the actual y position we modify, y pause, is going to be row multiplied by the height of each row. So then we take every pixel from that range and move it to another range. I think it actually makes more sense to generate a new image based off of the source image. So let's create a new sprite. The final sprite will be a new sprite made out of the size or dimensions of our previous sprite. So let's say, I think they're individual arguments, so width and height, to create a new a blank image. And then we just copy each pixel. I don't know if alpha will be included. I feel like it's not going to, so I think we need to enable in the engine the pixel mode called mask, because we don't allow transparency inside of our sprites, but we do allow for this blank pixel. So we need to at least use the mask pixel mode, which means if it's got any transparency, it will be rendered invisible. So with that in mind, now we can go ahead and make it so we adjust, or we basically reprint all the rows, but in the correct order. So the source Y pause is now going to depend on, so the way we have to do this is every 4 rows is a significant set of rows. So how do I want to do that? It's like for every 4 rows, we have to iterate through them. So this is like, I'm gonna call this an animation row. And this is based on however many of these there are, divided by 4. That's the animation row we're on. But then the actual row we're on is going to be between 0 to 4. And so the initial offset of the animation row, so we're going to say animation row Y offset, is going to be the current animation row index multiplied by the image dimensions.y multiplied by 4. And then from there, we offset the actual image row we're interested in. Y pause. By taking that animation row Y offset, and then we're going to add, based on the current image row, multiplied by the image dimensions height. That way, for every one of those, we're adjusting between either animation row 0, 1, 2, or 3. And we're doing that over and over and over. So after that, we need to grab from a certain position. And this is where the offsets come into play. So based on the initial animation row Y offset, we have to adjust where we're taking our new image row to. So initially, let's see here. So we're doing them in order, but where they retrieve their source pixels from will vary based on this right here that we specified earlier. So it's going to be plus row offsets of image row multiplied by the image dimensions. So as an example, we, inside of image or row offsets, we said that the north row is actually 48 pixels off here. So, which is, we said it's -1, no, it's, did I do this backwards? Maybe I did this backwards. I don't know if this gives us the correct information yet, but we're gonna take a quick peek. I might have done this backwards, because I forget what's in row offsets. Did it, like, crash? It crashed. Oh, we changed the arguments, that's why. So I'm gonna go in here, and we're gonna add... I want to say it's in... I forget where this was. Advanced? No. Is it just in here? I forget where the command line arguments were. In here? Command line. No. Where'd it go? Oh, here, debugging. Okay. So, I should probably be using a terminal for this now, but we're gonna say these are 48 by 48. For the sake of testing. Okay, try that again. Okay. So, I'm gonna look at these again, because I forget how this works. So, we said... So, right now, animation row is 0, which means all the offsets are 0, right? And Y pause, or image row, is 0. So everything's zeroed out right now. Nothing should be, like, weird. So what this is going to be is take the first image row, and it says it's 2 lower. It should be 2 lower. Let me think about that. So it's more like an operation. It's gonna say, okay, we're gonna start from here, and we're gonna go down to the first row, then the second, then the third. And what do we do with this? We offset it by X or Y amount. So that's how we're doing this, actually. So in that case, Y pause, or source Y pause, or well, we're calling this the destination Y pause, is going to go from here, wherever those pixels are, to wherever here is. And then we just print those pixels. So on the final sprite, now we iterate through all pixels and copy them over. So I think we have to do... Ooh, there's a cool way we can do this. We can say set draw target to... I think this is supposed to be for a sprite. I'm pretty sure. Yes. So it's actually a sprite pointer. So we're going to say we're drawing on final sprite, and then we're going to use the draw functions of the Pixel game engine. So we're going to say draw partial sprite, and we can specify dimensions in here. And we're going to start at Y position or X position 0 and go to Y pause, whatever our current Y pause is, to 48 pixels down, or image dimensions.y. And then for the sprite we're drawing from is this S sprite. Needs to be a pointer. And then we have the source position. So the source position is going to be the destination Y pause. No, I have these backwards. The destination Y pause is going here. The source position Y pause is going here. Okay. So I had those flipped. And then the size is just going to be the width and the height. So we're just going to use, well, no. It's image dimensions.x and times, no, it's just gonna be the width of the image. So s.width and s dimension or image dimensions y for the height. We don't need to scale or flip it, so that should work. And then we can call, instead of s save to file, we call final sprite save to file. So let's see what happens. We're just gonna run it. It looks like it did something. Let's look at the result. So it didn't make a new image because it's still 0.png, which is incorrect. Oh, you know what? It actually used the same file name, which means I think it just overwrote my file. Which, good thing we loaded it up in the editor because we might have to redo it or something. Skeleton warrior.png. It looks like it was modified at... Looks like it wasn't touched. So that's interesting. Oh, it looks like it's saved as skeletonwarrior.png.png. There's an extra PNG there, which kind of makes sense. Let's just take a look. So... It's trying to do it. It looks like it's almost what we want. In a sense. So let's debug and see what actually happened. Because that's kind of interesting. So what I actually want to do is I only want the ending of this. So I want like images to load index dot substring from the find last of a... Find the last of the backslash characters or / characters. I think it would be backslash because of the way we specified it. And then use that as the start and just get everything else. That way it saves it local. So if I just ran this again, now it's going to put in my local folder. At least I hope it does. Because I wanted to overwrite my files. So I'm going to back up here. Still didn't do it. Why? Maybe it didn't find it? Let me see. Oh, are we not... Did we throw or something? Or did I not stop it? I think I didn't stop it. Oops. Yeah, it like recompiled and stuff. Okay, it still didn't do anything. Okay, let me just try this. Find, save to file. File name, oh, there's a slash in front of it. So it probably went to my, like, root drive or something. Which would be this? I don't know where that would be, but... Or maybe my home folder? No? I don't know where this would have gone. No idea. But we'll just say that it's lost. So what we need to do is remove the, or go one character after that. So it's like +1. Classic off by 1 error. It's probably just an invalid file name, to be honest. Also closed File Explorer. Okay, we have to go back. There it is. Okay. So that's right. I noticed there's a black pixel going across the entire bottom. I guess we need to clear the image first. So we'll set the draw target to final sprite. We'll go ahead and clear the entire thing. So clear to blank, which should make it completely transparent. And then from there, we can draw on an invisible sprite. So let's debug this a little bit, because it looks like it doesn't quite do what I need it to do. So we're just gonna step through the code. So here's animation row. I thought I did this earlier. Image row. And let's get these guys up too. I think that should be enough for now. And maybe the array offsets. So we know that the first slot is considered the south slot, so it needs to be adjusted 96Y pixels off. So this looks correct. And the source pos is supposed to be from the 0 position. Image dimensions.y should be 48. So I think we're looking good here. So I'm not worried about any of that. We're just going to proceed to the next one. So image row 1, according to our offsets, image row 1 should be offset by, I think, -1 rows. Yeah. Let me just pull these up too. So row offsets 1 needs to be set by -1 rows. So that makes it go from 48 to -48. Why is it 2 off? Animation row y offset 0 plus -1 times 48, which is -48 plus 0. Okay, that's not right. It should be using y pause here. So that's a typo. I think that should fix it. So I'm just gonna run it again. No breakpoint. Let's take a look now. So the sprite sheet is transparent, and now it's northeast, southwest, northeast, southwest, northeast, southwest. Perfect. So the tool does what we need it to do now. Now, can we do it across all of our sprite sheets? Well, I guess the first question is, are all of our sprite sheets the same way? And I guess also it depends on what the sizes of them are, because they vary. But I guess doing them each individually isn't a bad idea either. I'm also gonna... I think we'll do this in a terminal now, because we need to, like, pull file names and stuff and do different things in it. So in our terminal, we're gonna go ahead and call this, and then we can specify our stuff. So we'll just do it in here now. So now let's pull up each of our things. So we have the Dagger Goblin, or no, Skeleton Barbarian. Also, I need to get rid of that one. So this one is... yeah, it looks the same. We need to figure out the size of it, though. It looks similar. It doesn't look 48 by 48. There's 300 pixels across 5 frames, so... 60? I guess that would be 12 more after 48. So it's 60 by 60. Also, this is wrong. So it's currently, so I think they're probably all gonna be south, north, east, west. But then this one's 60 by 60. So that ran... I kind of want it to auto-close when it's done, instead of staying alive, so we can... let's write here, return false, and then it'll just auto-close when it's done. Maybe we'll write, like, the something that says we're done. Done. That way we know it didn't, like, crash randomly. Just rebuild. So Skeleton Barbarian should now exist in the correct order. So north, east, southwest. Looks good. And we'll just go through all the sprite sheets and make sure they're fixed. So Skeleton Archer. Can I remove this AI actions right click? I really don't like that it exists. App actions. How about not? Remove background with paint. Visual search with Bing. Where is this AI actions thing coming from? AI components? None are installed. Can I get rid of it? Text and image generation. Windows and anyone using this device can use text and image generation. No. Recent activity. See which apps have requested access to text and image generation. On-screen indicators. Okay, that's fine. Not what I'm looking for. Let me see if I can get rid of this. AI actions context menu. Windows 11. Add or remove AI actions context menu. You can remove it. Open settings, go to apps, click actions. I thought we were there. Turn off all available app actions to remove the AI. Oh, they are AI actions. Oh, hey, it's gone now. Hooray! Okay, good. Anyways, Skeleton Archer is 48 by 48. So just go ahead and run that real quick. We have to like... Let me just make this so I don't have to keep like typing that over and over. Done. Good. And then we have the Skeleton Captain, which is this one. It's still there, but now it says no actions of it. This is stupid. This is actually stupid. Every day we stray further and further. This looks like way larger. 24, 48. I guess this is also... No. This might be 60 by 60? No, 256 divided by 4 is 64? No? I can't math. Oh, it is. So this is 64 by 64, I guess. Oops. Okay. And then we have the Skeleton Fire Mage. So I think what I did for these, they're just like palette swaps. Skeleton Fire Mage. Yeah, they're just like palette swaps. So these should all be the same, in theory. The next three. So we have... I think that's 48 by 48. I guess I could put them all at once, couldn't I? Frost Mage. And Lightning Mage. Okay. I'm glad I added that. That's convenient. And then we have... Snake. Also 48 by 48. Let me just check the rest. Spider. Spooter. It's actually the last one. That's not a spider. Where's the actual spider sprite? Hello? Did I not save it? Oh, that sucks if I didn't save it, because, like... That means I have to redo the sizing and everything. I think it was, like, pretty good, though, because it wasn't, like, a complicated sprite. Yeah, I'm gonna have to grab that again real quick. Dang. Okay. I don't think there were any problems with it, just we had to grab... Yeah. Is it 48? It does... Oh, you know what? We have to move the centers, though. That's what I mean by, like, getting the sprites game ready is, like... If they're not centered, they're gonna look weird when they, like, turn and stuff, so... We just have to move them to be on the centered axis, and it should be good. And then I guess I didn't save it. That's the only issue. That goes in here. Oops. Under spider. Okay. And again, the facing directions are incorrect. So we do have to fix that part. But luckily the snake and the spider also need to be adjusted in the same manner. And they are the same size. So it's just simply bringing these two in. And then I believe all of our sprites are now successfully converted. North, east, southwest. So I think what I'll do is I'm also going to add this little tool to my repo so that I have it in the future, just in case. But we need to bring all these guys back into here and replace these. And then the other one is in here. So bring Skeleton Warrior. And then I'm also going to bring the tool over. This is a debug build tool, but I don't really care. I'm just going to throw it in our main Adventures in Listoria folder where we have all of our utilities. That way in the future, if I have to do sprite conversions, it'll be right there. I wonder if it makes sense to put it in the images. Nah, I'll just leave it there. But yes, we have a nice little tool. I think I'll make a repo for it too in case we have to like do something with it. Just real quick. I don't want to like lose it by accident. So this is the sprite sheet organizer. You never know. If my computer goes kablooey, I don't want to have to redo this. I don't want to have to rewrite this today. And then grab this, go in here. Let's create a Git repo. Actually, let's just clone it since I already made it. Oh, I have to clone. All right, we'll just create a local Git repo and we'll link it to the remote, which existing remote, create and push. Wait, what did I just, okay, yes. Looks like that's all done already. Okay, I accidentally committed the PNG, but I don't care. I'm not worried about that. So, now that we've done this, I'm happy that I made this tool today. So, what I was originally going to do was we were going to actually implement the animations into the game today, but obviously a little side quest to make this little tool. And we still have to do the snake AI. So the snake AI is interesting in that it's like the dagger goblins, which stab, but every time it attacks, it also dashes 300 range forward. So essentially what we're doing here is we're gonna write... Also, why is this complaining? It says it doesn't think this is a valid class. I want to say it is a valid class. Like, is it not? Am I crazy? Maybe I need to include a monster? There we go. Okay. It's just, it's defined a monster, that's why. So, basically what we're going to do is we're first going to run the Dagger Goblin strategy. That's going to be the same. So run strategy. Does it not know this? Oh. Needs to be our monsters run strategy function. And then we can specify... Dagger Goblin? So by default, it's going to just run this. And it's going to try to use the same animations from this thing. But then every time it attacks, we have to do something special. So, I don't know how exactly I want to do this. We're gonna have to see. Because I go one of two ways. I either copy all the code here and then just modify specific phase stuff. Or I do something else entirely where I rewrite this to handle extra customizable stuff. Like adding the dash into the base functionality so it can be used out here. Or I can add a flag, and if I add a flag that says has attacked or something, then it could be used out here. That sounds like a pretty decent idea, considering I don't want to make it this too complicated, and I really don't want to copy paste this because the AI is a little complicated. So I think we'll do that. So between the stabbing and the slashing animations, which the snake doesn't care for, it will move forward with both. We're going to make it so we add like a has attacked kind of flag. So we're going to pull up our monster attributes. And let's add a has attacked flag. Okay. So then, let's make it so at the beginning of every tick, the monster's has attacked flag is going to be set to false. That way it's reset. And then it will be set to true every time the windup for these attacks have finished. So it really needs to be in here. Or maybe during the recovery time. Because they both go into recovery after this, right? Attack recovery time. I'm just confused if the attack happens now or later. So let's take a look. Dagger Slash's update function. Okay. So in here, it looks like it's just alive the whole time. So I'm gonna move back and we're gonna say, oops. Has attacked becomes true in here. And then on the frame we attack, we can do the lunge. So if has attacked, then we're going to do a lunge. So we can modify or control like the velocity of the monster at this point to leap forward. So we can get the current like facing direction components. So here's direction, and then I think based on the direction enum, we can convert it into like facing direction, a facing direction vector essentially. I know the player has one of these. We might have to borrow from it. Yeah. So we essentially need this. A function that returns based on the facing direction of the monster what the unit vector is relative to that facing direction. So we can implement something very similarly. And we'll just make that a new const function in monster. So we'll go down here, we'll make it public. And we'll put it right around here. And then we should be good. Cool. So then we can utilize that here by taking it, and then we can multiply by some velocity amount. So we'll have this. I think IntelliSense is just being really slow. We'll just multiply by we need a variable for this. So let's go in monster strategies. We need to make a new snake monster strategy. I assume one doesn't already exist. And then in here, we're gonna write... I don't know what to call it yet. Let's just call it like the attack lunge amount. And then we'll just set it to like 300 by default. Because it says in the spec that it wants to leap or dash 300 forward. I guess it's like dash lunge amount. Dash attack amount. Maybe something like that, right? I think that would work. It doesn't like this. It's supposed to be a VF2D. Monsters no member get facing direction vec. Do we call it something else? Get facing... Oh, dir vector. Oh, okay. I was close. And then... yeah. So we'll call it dash attack amount. We'll say it's 300. And then I think we're pretty much good there. I would test it, but we have to first implement the animations that this requires. So I'm gonna go up here and just say Goblin Dagger. I'm gonna grab all of its animations and just straight up copy paste it into the snake, which doesn't even have an entry yet, funny enough. So we have to make one. Let me just make it right here and copy this monster. And inside of here, I actually don't know what the stats are either. Snake is 400 health, 30 attack. Oh, it also has an on-hit poison. Okay, that's interesting. How do I implement that? I could put it here, but this is assuming that it can only attack the player, which I guess it's a safe assumption. If it's attacked, there's only one thing it could have attacked, in theory. But it's like, it needs to actually hit the thing. So it's like, we need to pass a property into either Dagger Stab or Dagger Slash that if this hits, it will also poison the monster, or poison the target. And by doing that, we're also gonna have to change, like, these images specifically for the snake. It'll look funny right now. It'll look like the snake is, like, trying to use a dagger to stab the player, which is hilarious. But that's just how it is for now. So I think we'll add a property for that. I don't know what to call it. I almost just want to add it as like a variable that I can modify on the fly. So I can add int on hit poison amount. And then I would do the same for the dagger slash. And then if it hits something, then we're going to make it apply poison to whatever it hit. So it would be player, add buff. We also have to specify how long the poison is. So it would be 6 damage for 3 seconds, per 3 seconds for 9 seconds. That's a lot of extra data to include. It's like, I almost need to include the buff class in here, which is wild. Like, I would provide a... It would be like an optional then. It would be a buff I can specify to be applied to something on hit. On hit, apply buff. Because this is a lot more flexible. This could apply like slowdowns too. It can apply a lot of things. And that'd be fun. Okay, so... Then we can say add buff only if on hit apply buff is true. Or if on hit apply buff exists, then we would apply it. So add buff. I don't know, like, I don't have one for just adding a buff, like copying a buff directly. I feel like that would be useful. So maybe we should add that, like, and place back a buff that's just a copy of another buff we supply. I guess I've just never done it this way before, but that would be cool. So we add this. Because I don't really want to update the buff list directly. I really just wanted to add a new buff using this function in case there's other behaviors we have to do. I wonder why we need player. That's kind of interesting. I actually don't know. That is weird. Is this like not just the buff itself? Standard vector buff. Then that should be fine, right? I don't know why there's a this. Oh, I see. It's like I have to look at the actual constructor of buff, where it includes like... Oh, wow. Wait, so this doesn't have a copy constructor by default? I feel like it does. I think all these types are copyable, so I think the default copy constructor should exist, even with custom constructors. I think. I hope. I'm not 100% on that, but let's just go with it for now. Anyways, I added this, so it should work, and it would also work for monster if I added it too. So I'm gonna go ahead and put those in as placeholders for now. And I think we know where we can continue tomorrow, because we are out of coding time for today. At least for now. But I hope you all enjoyed today's coding session. It's been fun. We'll continue more tomorrow. We actually spent a majority of the stream developing a small utility tool that just makes it easier to redo any sprite sheets that are messed up. Rearrange them. We used STB image to rewrite images to be correct. So that was nice. I think that's implemented. IntelliSense doesn't want to update yet. And then in here, or in Dagger Stab, this should now be available. Cool. And then we would do the same thing, but for Dagger Slash. In both the monster hit and the player hit functions, if there is an on-hit effect, go ahead and apply it. Okay, I think that's good for now. And then, what we would have to do is we can make it so when we create this bullet, we can somehow grab... I'm not exactly sure how to do this yet, but maybe we can, like, create a standard any that stores a lambda for the on-hit function, put it in Snake, and then when it runs the strategy in here, it will take that... Or I guess we could store a buff. Like, we could store... Maybe we have an initialization phase, and inside the initialization phase, we would do m dot a for any, or no, any attribute like on hit buff, and then say it's equal to a brand new buff that we specify. It'll be stored in there, and then that buff, this attribute will be looked for in here, and if it exists, it will then apply it. That's like the theory. That's what I would like to do. But yes, I'm gonna leave it at this for now. Good stopping point, and we can continue tomorrow. Okay, so for those of you that tuned in today, thanks for watching. Hope you enjoyed. It's been a fun little coding stream. And I hope we're back tomorrow. Take care. Bye-bye.